This is the Pantheon HS3, an absolute beast of a 3D printer, a $10,000 tank that spews molten plastic, and this is playing with all the cheat codes enabled. And this machine is absolutely insane. And I don't even think with my setup and the type of 3D printing I can do, I can even review this properly. But Pantheon Design, they sent me this over to try out and test and evaluate, and I'm gonna give it the old college try. So enjoy this first look at what happens when you go crazy designing a 3D printer, because sometimes crazy works. So what is it? First off, it's a 3D printer. That part I hope is obvious enough. It's an FDM 3D printer. It has an X, Y, and Z axis. It's enclosed. If you've used a 3D printer before, it's like that, only overkill to the max. We're gonna take a look inside this in a minute, but first off, this machine, it's probably not aimed at you. It's probably not aimed at me. This is a machine designed to compete against other top tier machines. We're looking at like the Vision Miner IDEX 22, the newly announced Prusa Pro HT90. So those are the type of machines this is competing against. You're not getting this machine as an alternative to your Ender 3 or even something like a Bamboo X1C. This is a firmly prosumer, commercial, industrial type 3D printer, and the price tag goes along with that, but a lot of the features and things that come with this printer also pair with that. So the first thing we're gonna do is we're gonna take this off this bench, put it on my workbench. I'm gonna take all the panels off of it, and we're gonna take a look at what makes this tick. So let's go ahead and do that. Okay, so in the timeline, we're actually filming this part first because everything's off this printer. It's heavy as heck, and I'm gonna be moving it onto the desk back there. So before I do that, let's do a walk and talk around the printer and show you just all the cool things about it and what it comes with and why it is what it is. So it's made in Canada for one. We actually have a Canadian built printer. This was built in Vancouver in British Columbia. So this is a Canadian printer. So for once I could say, hey, buy domestic. So anyways, we'll start up top here. So obviously we have ball screws here. This is not Core XY. This is what people in the 3D printing industry call just your standard Cartesian style printer. So we have clear path servos driving the XY motion. So we have two servos here for your Y travel, and then your X travel is another clear path servo back there. So that's 3 clear path servos for your XY. For the Z, we have 2 NEMA 23s, and those are on ball screws as well. The tool head is an absolute beast here, and the kit that they sent me came with a completely extra tool head. So we'll take a closer look at the tool head on the bench with the spare one. So this is the tool head on the Pantheon HS3. And as you can see, it's a monolithic tool head. It's all assembled in one unit. And that makes it really good because you can swap out the entire tool head in the printer in under a minute. It's 1 CAN bus connector, 4 screws in the back. It's dialed in location. So you basically just unplug it, undo your 4 screws, take the old tool head off, put the new tool head on, and off you go. So if you're in a production environment and uptime is super critical, which it usually is, this allows you, if you have something go wrong with your tool head, you have a blob of death or a jam or something, you can just swap the tool head, get the machine back online, and then you can fix this off the printer. So that's really nice to see. So this tool head, it's a beefy thing. It's got some weight to it, but at the end of the day, it doesn't really matter because that printer has ball screws and servo driven, and it just yeets us around like it doesn't care. So starting at the hot end, this is gonna look somewhat familiar to a Slice hot end, and that's because they've actually licensed the patent that Slice has for their hot end. So this is a dual 50-watt heater hot end, so 100 watts total. It does use V6 style nozzles. It does ship with a steel hardened nozzle that's nitrided. I believe it's a Fadus nozzle, 0.4 millimeter. The heatsink and the extruder appear to be all one unit here. It's all machined out of aluminum. We're using the larger Bondtech dual feed gears here. The extruder motor is in the back here. We have a blower fan for cooling of the heatsink, and then we have this radial fan down here for part cooling. Now, this machine is designed to print PETG and nylons, both glass filled and carbon fiber. So you're not blasting this a lot. I've been mostly printing carbon fiber PETG, and the stock profile has this printing with 35% fan, and that seems plenty good there. We also have a custom PCB here. So again, this is a CAN bus tool head. So you only have 4 wires going to the tool head itself, 2 for power and 2 for data. And then we have its own microcontroller up here, custom PCB in the back, and it's all mounted to this aluminum plate here. So yes, this is a heavy tool head, but it is stout, it is solid, and it works very good. And of course, yes, there is a filament runout sensor included. And as for the webcam, yeah, it's just a Logitech C920. Straight up, they just include a Logitech C920 as the webcam for this printer. For feeding filament to the printer, we do have a extra large size Bowden tube, but that's really good because it's going to keep a nice smooth radius throughout the whole bend pass. So these filled filaments that this prints that are usually pretty stiff filaments, much less of a chance of it breaking in the reverse Bowden there. And then also you may see these. These are actually pneumatic gas shocks for the top hat. So it'll keep the top hat open and closed. We do have drag chains here for all your wiring. It is a CAN bus tool head on the tool head. Inside here, we have the bed and we have the common plate. This is the coolest thing as part of this whole design. This is what I think is like the special sauce that makes the Pantheon HS3 so cool. And that is this common plate. 20 millimeter thick machined plate of aluminum. And as you can see here, all the XY motion system mounts to it. The rails are indexed off of it. It's all nice and machined. It's anodized. We have our rods here for the Z. These are press fit into there, I believe. I believe they're press fit. I don't see any fasteners. So those probably are never coming out. And the rods are only supported at the top. Everything is on this plate. So when you look at the printer, obviously it's a cube. We have aluminum extrusions. These aren't actually part of the motion system, because one of the cool things is compared to like a more traditional printer design where you build your frame out of aluminum extrusions and then you mount everything to it. If the printer bends or moves, or even if it's like a bigger printer, and I know this affects like Prusa XLs, where if you have the printer on a desk and the desk isn't perfectly flat, you had something under a foot, or it's not a flat table, the whole frame twists, which kind of screws up your motion system. With this printer, because everything is mounted to this thick common plate here, and everything is referenced off that common plate. Nothing is attached to the actual frame. The frame is just kind of to keep this up in the air and allow you to enclose it. The actual entire motion system is only attached to this common plate. So that means this printer is extremely stable and extremely rigid. Insofar as much as you can pretty much shake this printer as it's printing, and it will not affect print quality or affect it in such a minimal way you'll probably never notice. Now, your printer shouldn't be shaking that much when it's printing, but we've had it on this wobbly desk here while I've been printing some prints and whatnot, and yeah, I've been having no issues with this printer and the print quality for it being on such a wobbly desk right now. And it's gonna get even better because I'm putting it on a more rigid desk after. So the common plate is really cool. We have vertical extrusions here. This is just for, basically enclosing it and having it so, it's not just sitting on these little rods and ball screws. That would be a little awkward. On the side here, this is what the filament storage solution is. The kit they sent me came with 2 of these. They are dry boxes. They are stainless steel. They're nice, high quality. They're heavy. It fits their 3 kilogram spools of filament quite well. Has a hydrometer in here. It is hot and humid in my garage right now, so this is doing the best it can. You basically just throw desiccant packs in there to keep everything nice and dry, and it feeds directly into the printer. No, this is not an active dryer. It's just a dry box, but I'm assuming the people that are really using this printer the most, filament's pretty much just going to come right out of the vacuum sealed bag, go right in here, and they're going to print until that spool's empty. If you have a machine like this, it probably doesn't have a ton of downtime on its schedule. So these boxes, the filament's not going to be in here for a crazy amount of time. We have a nice 7-inch touchscreen here. It's not on because the printer is on. And yeah, all the wiring is really nice. We do have this fan right here. So this fan sucks in air from below and blows it up top and basically allows the enclosure to act basically like a convection oven. So like a Voron, it doesn't have an active chamber heater, or at least this model that they sent me does not. But between it being insulated, enclosed, the convection air, and the bed heater putting out a bunch of heat, plus 100 watts of heater in the tool head itself, this chamber under normal printing conditions with everything buttoned up is plenty warm enough to print your nylons and your polycarbonates and your ABSs and whatnot. So I'm not too concerned about the fact that it doesn't have a chamber heater because it is so well insulated, and it's putting out enough ambient heat as is. So let's go to the back here. So back here you can get a better view at the X ClearPass servo here. Normally there's a plate on here. I've taken that off. And again, all the exterior plates here are this nice, I'm assuming this is stainless steel. It's got weight to it. I don't think it's aluminum. All the nice laser cutting and whatnot for fans. So we do have a nice big fan here blowing air in, and then it vents out. This whole back area here is separate from the actual print chamber. So with the panels on the side, this backpack, this internal backpack is separate. There is some holes obviously here for like cables and whatnot, but for the most part, this is pretty well boxed in. We do have a big fan right here for part cooling the control board, and first thing you're gonna notice, this is just an off-the-shelf Manta M8P from Victory Tech with a Pi CM4. That's pretty much off-the-shelf hardware. Even though we're using ClearPass servos, this is just running Clipper on a Manta board. Now there are some special components here, as you can see through the fan here. Only the Z motors are on drivers, and I believe they're 5160s or 2209s. They're more beefy ones, but those are on traditional step stick drivers, whereas the X and Y motors, they're ClearPass servos. So they're doing their own thing. I'm not entirely sure. There is a breakout board back here that they plug into. I really don't want to mess up with all the wiring. It's such a clean job back here. So I'm assuming they're doing some sort of translation between there and the ClearPass. Running servos isn't something completely out of the ordinary with Clipper. For those that know, the Magneto X has linear motors for its XY motion. It's also running Clipper with a off-the-shelf board. So they're not the first to do servos with Clipper. It can be done, but the version of Clipper they're running is a forked version of Clipper. So you are relying on them for updates, but you can still get into your printer.cfg and change stuff and whatnot. I've already gone in, I've had to reinstall Clipper screen for a Wi-Fi bug I was fixing. You can get in there and do your normal stuff if you want to muck about with Clipper. It's just, they do have a forked version of Clipper this is running. We do have this nice little board here. This is a Pantheon power distribution board with a bunch of fuses and a big cap. The power supply on this thing is massive. At first I thought this was a mains powered bed, but this is a 750 watt 24 volt power supply. It is a Meanwell. And we do have a solid state relay here. So there's no markings on the bed heater itself. But as far as I'm aware, this is I guess this isn't a mains bed. If this is 750 watt, it might be running a 24 volt bed. The bed heats up relatively quick, so they are pushing a bunch of power to the bed. I'm not sure. I'm gonna have to look into it to see if it's a mains or a 24 volt bed, but either way, it heats up fine. I've had no issues with it. It's not like it's a lack of power or anything, but that's just something when I opened it up and I saw the 750 watt power supply, I was like, huh, that's interesting. External Wi-Fi antenna, good to see. And it does have Ethernet, if you do want to plug in Ethernet for that, keeping things off the Wi-Fi if security is kind of an issue for you. And then we do have our power inlet there. Everything is nice and clean back here. They did a very good job. For the bed, it's your standard cast tooling plate. It is a kinematic mount under there. We do have PI flex plates on it, of course. It is 300 by 300 by 300 print volume. The machine itself is 600 by 600 by 650, I believe, and it weighs about 100 pounds. This machine is an absolute tank, and it's a beast, and my one suggestion is they do need handles. Moving this around when it's all paneled up is a pain. There's nothing under it. So as long as you're putting it on a flat surface, there's really no pinch point here because you have the feet, and these are the grippiest feet I've ever seen on a printer before. So you can lift it up from underneath and put it down on something. It's just, moving it around or picking it up and putting it on a shelf is, you definitely want help. You don't want to do it by yourself. Now you may be asking, how well does it print? And the answer is, well, it prints really good. These are some parts for a Nerf blaster I'm currently building. The SBL, these are all CF-PETG. That's what I've been mostly running through this machine. I've only had it for a week. I do have some carbon fiber nylon and glass-filled nylon to play with, but I'm saving that for some more adventurous projects down the line. So for now, I'm just doing the CF-PETG, and these prints are just coming out amazing. Now, the astute among you will say, oh, that's carbon fiber filled. That's cheating. It hides all the blemishes. And this machine is designed pretty much exclusively to print filled materials. So what happens when we take that CF-PETG profile and just take the profile, change your temperatures, change your fan, and just throw some ABS at it? Well, pretty good prints. There are some minor cosmetic blemishes, but nothing I'm too concerned about. There's some over extrusion on the top layer, for example, because that's all stuff you can fiddle with in the slicer. That's you know, a little bit of tuning a couple test prints and you're drastically increasing print quality. But what I want to say is these prints, fully functional, fully dimensionally accurate. I've got a bunch of threaded prints here. They all thread together. These are the Voron test prints for those that don't know. Everything just mates together perfectly. I measured this cube 30 millimeters by 30.05 millimeters by like just a hair under 30 millimeters on the Z. This machine just cranks out amazing parts. Overhangs are great, and this is ABS, of course. Now, it doesn't have a active chamber heater, but you are getting, according to the measurements, according to the machine itself, it does have a chamber thermistor. We are getting above 50 C in the chamber with the exhaust fan off. So it's plenty warm enough to print ABS. It doesn't come with an ABS profile, and officially, the machine is meant only for the CF and glass-filled PETGs and nylons. Those are the only official profiles they support. Those are the only filaments they sell on their store. But at the end of the day, it's a 3D printer. It eats normal G-code, so if you take the time to tune a profile, you can print pretty much anything on this machine other than like the Ultims and the PECs and the PIs and the other super exotic materials. So anything other than those, this machine should have no problem printing. You just may have to roll your own profile. And as for official support, you might be wandering to the RB Dragons territories, but I'm sure you can make do. I can say, while I've only had this machine for a week, and I've mostly been doing some test prints and some small other prints, I am absolutely blown away by this machine. And on top of all of it, it's quiet. We're talking like Prusa levels of quiet. There's no belts, there's no bearings, it's just ball screws and servos driving it. Yeah, there's NEMA 23s on the Z, but the Z don't move that much, let's be honest. And since it's printing materials that you don't need to have current air coolers blasting away, and while the machine can move crazily fast, it can move up to 1.1 meters a second, its printer profiles are more tuned for just consistent reliability. I'm sure if you took the training wheels off and rolled your own profile, you can crank out prints out of this thing absurdly fast. You got 100-watt hot end and servos and ball screws for your motion. But that's not what it's meant to do. This machine is designed to just eat plastic all day, every day, consistently, reliably, and print things that are mission critical. You're throwing full plates of parts on this machine that it just needs to succeed. It cannot fail. Or you're printing props for a movie and you need 30 helmets done by the end of the month and you just need to print. That's what this machine is for. This machine is not for little Timmy to print the current mean print of the month or so you can print Flexi Dragons for your Etsy store. This is a machine for prop houses, low volume production, prototyping of commercial industrial products. I know some of these machines are in prop houses making movie props. Some of them are in car shops, auto body shops printing car parts, replacement car parts, prototype car parts, intakes, that sort of thing. This is firmly a professional machine, maybe above even prosumer. This is a commercial industrial type machine, and it shows. This thing is an absolute beast. It's an absolute tank. I've only had it for a week and I just can't wait to keep putting more hours on this thing, put more prints on here. I've got some ideas for projects I want to do on the channel that are going to use the glass fiber nylon and the more industrial filaments. And after seeing this machine at trade shows in previous years, talking with the Pantheon team over the years, I am so happy that I finally have one of these to play with and toy with. So I hope you enjoyed this quick first look overview of the Pantheon HS3. Again, massive shout out to Pantheon Design for sending this printer over to me for testing and evaluation. No money exchanged hands. They have sent me the printer free of charge, but they haven't seen this video before it went public. Words and opinions are my own, blah, 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 usual YouTube disclosure. If you want to help support the channel, the content I create, and the things I do, consider checking out some of the links in the description. Consider becoming a channel member or Patreon supporter, or check out some of the live streams that we do weekly. I'm Taylor, the Canuck creator, and I hope you enjoyed the video today. This has been fun. Cheers.
Well, that's one way to do it.